Hi friends, welcome to my YouTube channel. This is second part of lecture number 20, and in this lecture we will study parameter calculation for one phase half wave and control rectifier with a load. So first, average output voltage. We know that average voltage across inductor is equals to 0. That's why V naught average is equals to 0. So it is evident from waveform of V naught where two shaded yellow areas are equal. That's why we can say that average of this waveform is equals to 0. Now next is what is I naught average. We get output current I naught from alpha to beta. So to get the average value of output current, we will simply integrate the equation of current from alpha to beta. So on integrating this, we get the output average current. Now what is output average voltage? Output average voltage is simply equals to 1 upon 2 pi integration alpha to beta V naught square d omega t, and V naught is equals to Vs, and that is equals to Vm sin omega t. So integrating square of Vm sin omega t from alpha to beta and divide it by 2 pi and take square root of whole, we will get output RMS voltage. And similarly we can calculate output RMS current, that is simply equals to 1 upon 2 pi integration alpha to beta I naught square dot d omega t and under root of whole. But actually this is not very much important, only you need to emphasize on these two, that is V naught average and I naught average. Okay. Now next is this load is current step. Why it is current step? Because voltage and current waveforms are not similar. That's why this load is current step. And this is half wave control rectifier. Sorry, this is control rectifier. Okay. Now next is output power P naught is equals to V naught average into I naught average. So for current step load, output power is always given as V naught average into I naught average. Now next is to calculate the power factor. We know that input power is equals to output power. We have to put it, so we get input power factor from this equation. Now what is conduction angle of thyristor? We know that thyristor conducts till we get the output current I naught, and we get the output current I naught from alpha to beta. So that's why conduction angle of thyristor is equals to beta minus alpha. And we know that beta is equals to 2 pi minus alpha. If we put this, then we get 2 pi minus 2 alpha. Now what is excitation angle beta? We know that we get current up to beta, and beta is equals to 2 pi minus alpha. That's why excitation angle is 2 pi minus alpha. Now what is peak inverse voltage? That is simply equals to Vm sin alpha. Because see here, this is peak inverse voltage, and this peak inverse voltage occurs here. Okay, so this peak inverse voltage occurs here, and this point on this sinusoidal waveform is Vm sin alpha. Okay, because it occurs at 2 pi minus alpha, and we know that sin 2 pi minus alpha gives minus Vm sin alpha. So maximum reverse voltage across thyristor is Vm sin alpha. Now what is circuit turn off time? We know that thyristor is reverse bias only for this period, and this period is simply equals to 2 pi minus beta, or we can say that circuit turn off time is equals to 2 pi minus beta upon omega. Friends, although this lecture is not very important from exam point of view, but I covered this lecture to enhance your knowledge, so that you will be able to understand the concept of rectifiers more clearly. So this is all about this video. I hope you will like this video. Thank you. Jai Shri Ram. If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends, because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.